Hello everyone, welcome to this video. We will learn how to perform stick-sum data analysis using the fitting technique called stack fit. In the previous video, we learned how to perform stack fitting using SVD. So where to find the stack fitting? We go to the function stacks, maps, and we will find the stack fit next to the SVD. The key differences between these two is that in the SVD, the reference spectra will be interpolated in order to match their energies to the image stack. But for the stack fitting, you can use directly those reference compound spectra as they are, and the software will deal with these errors that may arise from the offset between the reference compounds and the stack fitting. So let's begin. I press stack fit and I will read. The software asks me to read the input data. The input data is my image stack prepared on optical density scale. It should be this one. Press no to read fit parameters. So as in the previous video where we looked at SVD fitting, I'm going to use 3 components or 3 reference compounds. So they are saved here. My first reference compound was calcite. I'm going to also delete unnecessary information. Remember from the previous video, if you use a long name, the output file will have a long name as well, because the name of the output file is a combination of the reference spectrum that you use and also the name of the root file, which is the input data. So that's why I keep it simple as calcite. My second reference is going to be aragonite. I also delete this information. So there is only aragonite. My third reference compound was calcium chloride. I'm going also to delete some of the unnecessary information. So the software will ask me to save. I can save this fit. Let's call it stack fit. And it will start performing the fitting. Remember, this is the root name, which is the name of the input file, which is my image stack saved as on optical density scale. Press enter. So these are yes, here it asks me to save the residuals. Yes, I can call them residuals. So now I have 3 component maps obtained through the stack fit instead of SVD. So another difference between stack fit and SVD is that you will have another component which is called constant. Remember, this is absent in SVD, but here it will appear. So this is my 3 component maps: calcite, aragonite, calcium chloride, but also it will add 2 more, constant and the residuals. So I can also remove some negative values of the OD or optical densities by pressing on the data that I want to process. Use the function images, clip signal, histogram, and remove all bad line or negative values. So by pressing on the left click 0 upwards. When done, copy the buffer here. So I go to aragonite, I perform the same task, images, clip signal, histogram, then remove negative values. Copy buffer. I go to calcium chloride. I do the same, images, clip signal, histogram, remove the negative values, save. And I can do the same for the constant. And the residual as well, but the residual looks fine. So these are the three components map that represent the chemical composition of my sample. I can also save them by using the write function, save as XCB file or graphics. I can save it maybe as a GPG image. My first component is calcite. My second component is aragonite. Yes. Save it as a GPG image, aragonite. My third component is calcium chloride. You can look at here. So it's aragonite. I can save it as a GPG as well, calcium chloride. I can also save the constant and the residuals. As we did previously, I can create a RGB composite map by using this function display RGB composite map. I want to assign calcite. I want to assign the red color to the calcite, so I should press 4 because the calcite is located in the 4th buffer. I want to assign calcium chloride here. I want to assign it with green, so I will press 6 here, and aragonite blue. Then I press here 5 because aragonite is located in the 5th buffer and it will be assigned a blue color. When I'm done, I can also press auto scale each map. So this is the RGB one. I save it like this. But also I can perform a similar task. RGB should be red. It's my choice. Calcium chloride will be green. I press 6, and aragonite here will be blue. Then choose not to auto scale each component so that I can see the difference between my images. So I call it RGB number 2. So basically, SVD and stack fitting are two ways to perform the fitting of the image stack so that you can obtain the chemical composition of the sample or the distribution of the chemical species across the sample. But they have some slight differences that you need to consider. So it all depends on how you want to perform your data analysis, if it's relevant to your data or not. Thank you again for following this video, and bye-bye.